Hi everybody, Shifra from Saturdata here to walk you through terminal and Git basics for data professionals. And this is actually the first kind of notebook tutorial that I'm going to be recording to accompany the podcast episodes of Saturdata Season 1, which is all about these technical data skills and using things in the real world. It doesn't get more practical than this. So just to give a little bit of background, each of these tutorial videos can kind of be enjoyed on their own, or you can watch them alongside the Saturdata Season 1 podcast episodes. And this is going to align with the first podcast episode about auxiliary data skills, where we talk about terminal, Git basics, why all of these things are important. So you can definitely enjoy them separately or together. If you could show the podcast some love, that would be amazing. So with that, let's get started. This episode is the first one, but it's going to be a little bit different because I'm not just going to be going through the notebook like some of the other tutorials we'll have in this series. I'm also going to be flipping back and forth between this notebook and my terminal, which I've resized in this weird kind of vertical window, which hopefully y'all can see and it's not too small. Let me just clear this out for y'all. And we'll be flipping back and forth so that you can see what things actually look like in the terminal, because in the notebook we can't actually run commands in the same way, and I want you to see this really, really hands-on here. The other thing I want to quickly note is my terminal may not look the same as yours. It almost certainly doesn't look the same as yours, especially for people who don't use the terminal that often yet, because you will. My terminal is kind of all tricked out with Starship, Capuchin, all these really fun themes and indicators that we will go through later in the notebook. So let's get into, why terminal is super important. I would say it's really about speed and integrating with engineering workflows, so you can navigate in the terminal really easily. You can manage Python environments. One thing that we'll kind of gloss over in this, you can run Marimo notebooks professionally, you can troubleshoot common issues, and do Git version control workflows, which is indispensable for practical engineering with your larger team. Mastering the terminal unlocks that speed, automation, tool access, and reproducibility, right? Being able to perform exact steps the same way rather than clicking on a bunch of different buttons in a UI that may change that you don't have control over. So it's just really, really powerful in that way here. So the first thing we want to start with is, how do you even open the terminal, right? So if you're on a Mac, and I'm sorry if you're not on a Mac, I can't help you. You'll use like Windows PowerShell or something. But if you are on a Mac, you're going to use Command Space to open your Spotlight search and type terminal. So if you're just starting out, you're going to use the terminal app. I actually use this kind of tricked out app called iTerm2, which is basically a fancy terminal where you can use formatting, you can install themes, plugins, and other kind of interesting things. But in this case, for now, you'll just open the terminal app, and I'm actually using iTerm2 here, but it all works the same way. So I'm going to open my iTerm2 manually, and once you have it open, you can, open it from the dock like anything else. And I want to kind of show you these essential terminal commands and try that out and see what it looks like. So every command is going to give you an output that gives you some information. So the first command is pwd. This command stands for present working directory, I believe, and it's basically telling me where am I right now in the terminal. And this will be important because we can kind of navigate around. So if I do pwd here and hit enter, I'll get users, Shifra Williams, that's my name. I'm in the documents folder, I'm in the repos folder, which is where I keep all my repositories, and I'm in the wrapped for LinkedIn GitHub repository, which is a project that I actually put out in December, which is basically like a Spotify wrap for LinkedIn. Super fun project, check it out if you want. But now I know exactly where I am. Even if I don't have any of these fancy little indicators here, the terminal can tell me exactly where I'm going to be. Now, if we want to see what files and folders are in this directory, we can hit it with an ls. And this is going to just list everything that's in here. So we can see there's a bin, there's a package lock.json, there's a readme, etc. There's all this stuff in here. If we want to find out more details, we can run ls-la, and this is going to tell me the permissions, the size, the date modified, and we don't need to worry too much about this now, but just know that you can really get a ton of information with this -la flag. Awesome. So now let's explore just kind of moving around the terminal, and I'm going to clear here. So let's run a quick cd tilde. And for those who don't usually type the tilde character on the standard keyboard, it's shift, and then the key that's next to the 1 key, that's going to give you a tilde. If you do it without shift, you'll get this backtick. But yeah, so cd tilde. And that's going to take us to our home directory. And as you can see, this has now changed because my indicators are kind of telling me where I am. If I hit pwd, we'll expect to see user Shifra Williams. That's my home directory, right? So let's say I want to get back to the wrap for LinkedIn. This is where we can really see the value of the tab autocomplete for terminal. So if we do cd, let's say documents, but I don't want to finish the word, so I hit tab. Then it's going to finish that for me, right? Then if I type R and I hit tab, it's going to know that the next thing I want to do is repos. And then if I do W, and hit tab, then there's a couple options. So this is where you really see the value and you don't have to remember like what's in which directory, which is such a pain when you're doing things with a click UI, honestly. And if I do tab after W, it's going to tell me, well, I have the website repo, I have the wheelchairs repo, I have the wrap for LinkedIn repo. So which one do I actually want here? I want the wrap for LinkedIn. So I'll type a couple more characters in that name, hit tab, and now it knows what I want. So I can hit enter. Great, now I'm back where I started. Just clear this. Clear is another great command for you to know. And one other thing that's kind of cool to show you here is that we can do cd ... and that is saying that whatever directory we're currently in, let's go back up one folder. So it's equivalent to like hitting the back button in the UI. So you see the list of folders that's one level up in the chain, right? So if I do that, then we're no longer in the wrapped for LinkedIn repo anymore. We're back in the repos folder, which we saw earlier. So if I go back into the wrap for LinkedIn repo and I do another pwd, we can see that like we're in wrap for LinkedIn, one level above was repos, right? So when we did our cd ... it took us one level above, which is just like so cool to visualize all this and know what's going on in your file tree without having to remember every single detail or type everything out, which is just so incredibly helpful. Great, so we've kind of gone through everything in this section and used tab completion. I'm going to clear and move on to the next section here. Now it's time to move on to the actual file operations here. If I create a new directory in here and I say make dir project, now at ls, and I can see, okay, project is in here, right? And now let's go into the project directory. So we'll cd into the project. And now if we do pwd, we're in project. So always good to like make sure you're in the place that you think you are, and we'll talk about why that's important later on here. So let's say I'm in the project directory, I want to create an empty file, right? So I can do touch analysis.py, and now if I ls, I have analysis.py in there. Great. So I can now also copy that file and say cp analysis.py as analysis backup.py. A little bit different from the notebook, but who cares? And now if I ls, I should have two files in here. So this is so cool, right? Like, see how fast I'm doing all these operations? Now we're going to go into Vim, actually. And Vim is really, really intimidating for people that haven't worked with terminal before, but I promise it's not as scary as you think. So right now, there's nothing in these files, right? But we want to change that. We want to add something. So what I'm going to do to open Vim is I'm going to say vi, and then the file that I want to open. So the file I want to open is analysis.py. Great. Now I'm in this empty screen. And what's really important to understand is that Vim has this kind of operational mode that is the default when I enter it. And then it also has a text editing mode. So to enter the text editing mode, we're going to hit I, and that means insert. And you can see insert at the bottom of the screen to tell us that we're in insert mode. So I'm going to say, here is some text in my file. And to get back from the insert mode back into the operational mode, I'm actually going to hit the escape key. And now that I've done that, the insert mode has disappeared. So now what I can do is I can save this file. How do I do that? Well, all of the important commands in Vim, for all of these commands, you'll need to type a colon. So the commands are kind of indicated with abbreviations by letters. What I want to do is I want to write this data, and then I want to leave Vim. So to do that, I'm going to type W for write, and hopefully you can see this at the bottom here. W for write, and then Q for quit. So again, this is colon WQ, and if I hit enter, now I'm done with Vim, which is super, super cool. So I don't know why it didn't exit the command. I'm just going to do a Control C. Control C will exit whatever you're in the middle of here. And now what I want to do is this cat command. So cat means concatenate, and it's going to just give me the contents of my file. So if I do cat analysis.py, then I'm going to see, okay, here's the file name, and then here's some text in my file. Now I actually have this fancy formatting on my cat command, which I forgot about, and I can share that with y'all at the end when we talk about tricking out your terminal setup. But you'll probably just see the actual text, which is here is some text in my file. Don't panic, it's not going to look exactly like mine, and that's okay, because mine is all tricked out here. But I think it's so cool that you can just pull the content of a file to see in your terminal workflow. Again, you don't have to double click anywhere, you don't have to open a new tab, just so much more convenient. Let's say this data is not very sensitive, right? It's just some random text, so we don't actually need this backup file here. So what I can do is I can say rm this file, and now that file is actually gone. So you can see why it's like so important that you're in the right directory when you're running these commands, because if I ran this from the home directory, I would get an error of like, there is no analysis backup file in here, right? And now if I do another ls, I should expect to see that there's only one file in here, the original analysis.py, and the backup analysis is not helpful anymore. So something we're not going to do, but we could do, is we could delete this directory and everything in it, which is again a reason why we want to be so careful with which directory we're currently in. And that's going to be this command here, this rm-rf. So be really, really careful with this command. If you're ever working with AI and AI wants to run this command, just think long and hard before you whitelist or allow AI to run that command, because that can be disastrous. I'd be remiss if I didn't showcase the open command here. So if I want to say open analysis.py, it's going to open this in some new window, which is super, super cool. That's pretty much everything here. So I think the one thing I actually didn't highlight here, I'm just going to clear out our terminal, is if I ls and I hold down command and then click, you can see this underline here, and this is telling me that I can almost treat this like a hyperlink, and I can open this file by clicking. So that's another really cool thing. So all I did here was I hit the command key, I held it down, and then I hovered over it, I see that line, and now I know I can click. If I'm not holding the command key and I hover over it, it's just regular text. If I am holding it, it becomes this link, which is, again, super, super cool. So I think that is some basic file operations. I actually am going to cd ... and now we're out of the project folder. We're back in the wrapped for LinkedIn root folder here, and we can actually rm-rf this project folder because we don't need it anymore. And now if we ls, we're no longer going to see that project folder. It no longer exists. So just super cool use of like basic file operations that are going to make you so much faster. I think we've learned a lot of the next section, this productivity tips, we've learned a lot along the way. So we can clear the screen with the clear command, we can cancel a running command with Control-C. Some stuff that we haven't seen is you can hit the up arrow key to see all of the commands that you've run successfully. If I hit the up arrow, it's going to give me the ls command because we just ran that. Importantly, if you write something but don't finish, like let's say I do make dir random dir, but I don't actually run it. So I'm just gonna click Control-C. Then if I hit the up arrow, it's not gonna give me this because I didn't run that. I didn't hit enter on that command. It's gonna give me the ls, which is now 2 lines ago, but it's still the last command that I successfully executed. So that is how that kind of works in this situation. And the other thing is we've only used the clear command so far, which is great. If you want something that is even faster than that, you can just hit Command K in the terminal, and that is also going to clear your terminal without having to type that entire word, because who wants to type entire words in the year of our Lord 2026, right? Awesome. And then if you want to see a bunch of the command history, you can type the word history, and it's going to show you all the most recent commands. So that's pretty useful when you want to say like, oh, I knew I ran something like 10 commands ago, but I don't remember exactly what it was. I don't know what I did here, some like weird drag thing, but let's get rid of that and clear. And then I think the last thing in here is really chaining these different commands together. So if I copy this, we can do a ton in one line here. So what are we doing here? We are doing make directory, new project, and cd, change directory into that new project, and touch readme. So what we're doing here is we are creating a new project folder. A directory is a folder. We're going to cd, we're going to go into that folder, new project, and then once we're in there, we're going to create a readme file. So you can do so much in one just by using this and. This is ampersand, which is Shift 7 on your keyboard. And if you use that and syntax, you can chain all of these commands together in one line, which is super cool. The one thing to keep in mind here is that this is chaining on the condition that the previous command finishes. So like we cannot cd into our new project if our make dir new project fails. So if your first command fails and you chain it together with another command, that other command is not going to run. So these are all kind of like sequential on the condition that the previous command finishes. And if this works, we should have a new folder called new project that contains a readme. So let's see if we can find that here. Great, so if we look at the PWD, we're in new project folder, so that exists, and then our ls shows us that there is a readme in here. That's a really good way of showing all of the file operations, all the chaining, and you can see how this makes you so much faster once you're fluent. Great, I think we're going to want to cd ... to get back to the wrap for LinkedIn directory, and now we can rm-rf the new project directory, and now it's going to be gone. It's not in here anymore. Super cool. Great, so we kind of did some text editing with Vim. Let's talk a little bit more about how that works. So you can open the file with vim or vi like I did it here, just Command K to clear this out for us. And inside Vim, you're pressing I to enter your insert mode, which we already talked about. You press escape to return to that normal operational mode, and then you type :WQ and enter to save and quit, or like the W for write and the Q for quit. But if you don't want to save, if you decide like, hey, I want to just abandon these changes, you can do a :Q exclamation point instead, and that's going to quit without saving. So again, WQ to save and quit, Q exclamation point to quit without saving. There's also the nano editor. I think I'll leave that to y'all to look into. That one you're gonna have like different operations. It's Control X to exit, Control X even on Mac, and then Y to save. It's personally not my favorite. I prefer Vim, so I'll leave that to y'all to look into. And now I want to get a little bit into version control with Git. So first off, what is the problem that Git solves? Why should you care about this, right? Well, before Git, and something that we probably all did when we were first learning data science and just kind of using these notebooks willy-nilly, we'd have a file rather that was called analysis final, and then you need to make a change, so you call it, final v2, and then you end up with like final, I promise this is the last one. Or you have like files stored in Microsoft Teams folders or Google Drive files, which is the absolute worst, with no history. You can't see how this file has changed over time, who's contributed to this file, right? So you have like these two problems of like, what is the source of truth of the actual real code that is the final version of the code, and then also where are you putting this file and how are you supposed to see like how it got to the current state that it's in. So Git solves all of this because it has a complete history of every single change that was made with something called blame, which I think is so funny. It's like one of the funniest things in software engineering operations is that like we call it the Git blame when we say, oh, Shifra made this change, Git blame on Shifra. It gives you that history so you can see who to blame for every single line, every single change. You can collaborate without a conflict, right? So like if Sam, my co-host, and I are working on the same file and we change the same line in different ways, so we have these like diverting versions of the code, we can do that with Git, and we'll talk about that in just a moment. But you can't do that with like analysis final, actually final, that is stored locally on my hard drive, right? You can also revert to any previous version. Because we are storing a complete history of every single change, I know that, version 8 had these changes, and I can then go back to version 8 if I want, if I don't like version 9, which is super, super cool. And all of that kind of gives you this professional development workflow because you can collaborate, because you can safely revert, and your changes aren't just immediately lost when you change your file completely. So before you're going to use Git and GitHub, you're going to want to brew install Git and brew install GH, the GitHub command line interface. And a command line interface, or CLI, is really just a tool that a product or person puts out so you can interface with their product or their tool in the command line. So you can think of like the Microsoft Word product is a UI, a user interface. But when it comes to developer tools, people love doing things in the terminal because again, it's reproducible, it's quick, it's really common. And so you'll have a lot of products that have both a command line interface, a CLI, and a UI, a user interface. And some things are just a CLI. Brew is a really good example. So Brew is like basically a way to store a bunch of developer fun things on your Mac. And I don't think that Brew, or Homebrew, which is the full name of it, I don't think that Brew is available in a UI. I think it's only in a CLI, so check me on that in the comments if I'm wrong. But like, there's no way to reproduce the installation of Git in your UI, right? So I already have these things, but let me just copy and paste into my terminal, just so you can see it's that easy to run this. So even though I already have these packages and tools installed, Homebrew intelligently knows that I still have an update. So it's still gonna do a bunch of stuff in here. And again, it looks really intimidating. There's like a ton of, HackerMan text flying at me right now, but I don't have to do anything. I just have to sit and wait for this to kind of install. So now it's telling me what it's doing. It's removing this, it's adding that, whatever. Because it's Homebrew, it's kind of this fun language of pouring, and you'll see that a lot, but I don't have to do anything. I just have to, sit back and enjoy the show. So I'm gonna go back to my root directory because I already actually have this repository installed, but what I want to show you is the Git workflow here of installing a repository, or rather cloning a repository, because that's kind of the language we use when we're installing quote unquote code onto our personal machine. So this is going to actually clone the resources repository, which contains all of the notebooks that you need for Saturdata so you could run them at home, which is super, super fun. So I'm going to copy this command. We'll run a couple at a time. So this is cloning the Saturdata resources repository and then CD changing the directory so that we go into it, right? So if I hit enter, then we're going to see all this feedback. It's cloning into the repository. It has this git remote, which is saying that it's looking at the cloud to see like what is all the code here, and then it's going to receive all that code. Essentially, this is pretty big, so that's why it took a couple seconds. If you just had like one file in there, it would be really, really quick. But that is how you clone a repository. Now, let's say we want to check on what has changed. In this case, nothing has really changed. We haven't made any changes, we just cloned it. But if I want to see what changed, I'll type git status. And it tells me that I'm on the main branch and my branch is up to date with origin main. So I think this is a really good opportunity to kind of show you the branching workflow in the terminal, and explain what Git branches are, why they're valuable, and then we can kind of see what has changed, make a change, and then, save that change. So when we talked about how Sam and I can do different things on the same code and have it still work and everything still be fine, that is what branches allow us to do. And when you think of Git, you think of everything as a tree because there are all these different branches of the code. So the main branch is like the branch coming out of the root of the tree. So like if the tree's going straight up, that's the main branch, that's the source of truth. And every tool you've ever used has a main branch. There is a main branch of Photoshop, right? And they publish that, and that is like the product of Photoshop. It's a little more complicated than that because like not all the code is going to be in one place for a big distributed product. So there might be like a Git repository for the front end, a Git repository for the back end, a Git repository for like the core functionality or the middleware that's being used. But essentially there's a source of truth, right? And now what happens when some developer wants to make a change to Photoshop? Well, what they're going to have to do is they're going to have to create their own branch. So that is just copying the main branch that is the source of truth, and then they're going to add some code on top of it and say like, okay, I'm going to add these, 10 lines of code to make a tiny change, and now this button is no longer blue, this button is now green. They have to create what's called a pull request, and the pull request is saying, hey, I have this code on this feature branch. I want to bring that code into my main branch, but I need your help. So they send it to me and they say, hey, Shifra, please review this code. And I say, hey, this code looks good to me, LGTM, that if something is good on the first run and it doesn't need any changes. And then what happens is they take that code that changes the button color to green. They merge that code into the main branch, and now they've made a change in a very safe, secure way. You can also add like all these tests on top of it, right? Where like before the code merges into the main branch, you have something called CI/CD, continuous integration, continuous deployment, which is saying that like before we bring the code into the main branch that's deployed, we need to run a bunch of tests. We need to make sure that like it works on mobile, it doesn't have this bug that we ran into that last month, etc. It doesn't interact with this other piece of code badly. And now you can see how like there's so much going on in the code ecosystem, and being a good software engineer, being a good data scientist is like step 0. And then the other steps are terminal, testing, all these kind of things in the ecosystem around code that is really important for you to know. So that's kind of the branching philosophy. And it sounds really complicated. I promise it's easier than you think. So let's say I want to make a Shifra branch on this repository. And now I think is also a good time to get into the indicators of what are these kind of rainbow things on my terminal telling me. So the pretty colors and fonts and rainbows, that's all like Starship and Capuchin themes. We can get into that at the end. But I want to talk about like what are these words in the terminal header telling me. So this is saying that I'm on the Shifra Williams user in the resources folder, because we're in that directory for the resources repository that we just cloned, right? Then we're in the resources repository and we're on the main branch, and then we're on 3.14. And something that's really helpful is it's telling us the Python indicator here. So sometimes the terminal will show you like you're on a certain version of an important platform that you're using in your folder, in your directory. In this case, it's telling us that we're on Python version 3.14. So Python, it's like pi. And then the last thing here is the time, which is 11:18 local time for me. So this is really, really helpful with this Git branch icon, because if I am working, I can try to remember like, oh, which branch am I actually on right now? And I don't have to think about it. So it's really just giving me a ton of information at a glance that's super customizable for whatever's good for you as you get more comfortable and mature with terminal workflows. So what I'm going to do here is I'm going to say git branch Shifra main. And this is saying git, you go create a branch. The branch is called Shifra, and you should copy it from the main branch, right? So if I do this, now I'm still on the main branch, right? So if I say git branch, it's going to show me all the branches. The branches are main and Shifra. Great. Now how do I switch into this branch? I'm going to say git switch Shifra, and now I can see that I'm in the Shifra branch. So I was in the main branch before, now I'm in the Shifra branch, and the main branch still exists. If I hit git branch, I can see the main branch is still there. So this is great. And what this allows me to do is I can now say git branch Shifra 2 from Shifra. So we can branch off and branch off infinitely, right? And now if I git branch, then now there's a Shifra 2, right? If we want to delete a branch, we can say git branch dash capital D Shifra 2. Deleted branch, it gives me some good feedback, and it has this like code that represents what that branch was. And now if I do git branch again, I use the up arrow to get to that command. Now there's no more Shifra 2 branch. Great. Clear to get rid of everything in the terminal taking up space on the screen right now. And now that we're on a Shifra branch, Now what we can do is we can make any changes that we want because it doesn't affect the actual main branch that's being deployed, right? Not that the Saturdata resources repository is like that important, like there aren't hundreds of millions of dollars riding on this, but if you're working on a big product in a FANG company, there kind of are. So it's really, really important that you work on your own branch here. So let's make a change to the README just to showcase like what that flow kind of looks like. So if I ls, I can see that there is a README in this directory. So let's just get into there and I'll just cat the README so that you can see what's going on here. But what I did here was I typed the cat RE and then hit tab to complete the full README word, then hit enter. And now I've concatenated the entire README file. Again, I have all these fancy line numbers, syntax highlighting. It's okay if you don't have that. This is all tricked out with a bunch of cool plugins and stuff. So I can see all that marked down rendered here. Great. So if we want to update this README, I'm going to say VI README. And now we're in this like bare bones rendering of what the README looks like, and this is probably what it looks more like on your screen. And I think that all we're going to do here is make some really small change just to show the difference here. Let's hit I, and now we're in insert mode, so we can actually make some edits here. We have this contribute section, so I think I'm just gonna say, thanks for your contribution, smiley face. Now I'm gonna hit the escape key. I'm gonna type :WQ, and this is going to write and quit, so it's going to save my change. And now let's clear and cat the README again. And now it's gonna show thanks for your contribution because we saved that change. So for most of you, saving a change is all you've had to do when you wanna make a change to something in like a Word document, and Git is a little bit different. Git has a couple different steps here. So obviously saving is important, but saving is like the first in a line of steps. What you need to do is stage your changes, which is preparing to commit, and say like, hey, here is everything on the stage of stuff that I want to send back to the cloud. Then once you do that, you need to commit your changes, which is formalizing that save of your changes. And it's a really good practice to add a commit message, explaining in your changes what you've done. So if you had a change that was like 1,000 lines or something, which you shouldn't do, now the person reviewing your code can see like a little one-line summary of what you've changed without looking at all of that code. And now that we've staged our changes, we've committed that we really want to make these changes, then we push. And pushing is taking your changes and putting them into the cloud. Now you can share the code across your machine to someone else's machine. That's when someone can come in and review that code. When you are doing this commit flow, you want to use really descriptive commit messages. If you see something like updates or fix stuff that's really lazy, we don't want to see that. We want to see something that's more like fix bug in data preprocessing. So our changes are saved, but we still need to stage, commit, and push. So I'm going to clear, and I'm going to say git add. We can use the dot to stage everything, or we can add just one file. So me doing git add readme.md or git add dot in this case are equivalent because we've only changed one file. So if I'm adding all my changes, I am actually adding just the one file in this case. Let's actually do one more thing before we stage. So if I say git status, then it's going to say, here's some changes, but it's not staged for commit. So I've modified the README file, which is what I did, but I have not staged it for commit yet. So that's just showing like how the git status is really, really helpful here. And now if I do git add dot, which is really just adding that one file, and I run git status again, now it's saying changes to be committed, right? Because staging has changed the git status here. Now I want to write a commit message. So I'm just gonna say like add thank you to the contribution section, because that's what we did, right? And so the syntax for this is git commit. You can do that by itself, but you want to add the -m flag, which is telling you that you want to add a message with your commit. So it's git commit with the message, add thank you to contribution section. And that has to be in quotes because it's a string. Then I'm gonna hit enter. Great, one file changed, 2 insertions. Now I'll check the git status again. Nothing to commit, working tree clean, because we have already committed our change, right? So now this is part of the Shifra branch, and all we need to do is push this. There's actually one more step here. If I hit git push, it's saying that the current branch Shifra has no upstream branch. So like the cloud doesn't know that I created the Shifra branch on my local computer. So before we push, we actually need to say set upstream origin Shifra. And this is just saying like the cloud should also create a Shifra branch because it doesn't have that branch yet. So see how git auto-corrected my mistake and prevented me from making a mistake, which is great. So I'm gonna do git push -- set upstream origin Shifra to create that Shifra branch while I push. Okay, I actually had to fix an unexpected issue here, but that's the nice thing about Git is that it gives you output. You can look up errors, Google things just like you always do, and then solve it that way. Let me do the git push workflow again here. Git push. it's going to say I need to set up stream origin Shifra. So I'll copy this, paste. Have to enter my password here. Great. Now I have pushed it, and it's actually going to give me a URL for the remote. If I want to see this branch in action, I can command and click, or I can copy the URL into a browser and actually see that remote in the web, which is super cool. And that's just, again, confirming that our code is now on the cloud. So what we did here was we saved our changes, we staged our changes, we committed them, and we pushed them while creating a new branch. The last thing that we want to focus on here is git pull. Git pull is basically saying that I want to get the latest changes from my team. So if I git switch to the main branch, this is the branch that everybody's working on, right? So like I'm only working on the Shifra branch and nobody else is, but on the main branch, other things could have come in, from earlier today that I want to pull into my main branch so that I am fully up to date with all the new features that are coming out in my company. So if I switch to the main branch and I do git pull, in this case, there's going to be, no real changes here. Here, let me actually do some cleanup. So if I git pull here, then we're already up to date. And this is, again, great information for us. We're saying that our code that is on our local copy on our machine is actually up to date. There's no other team members that have done any interesting new features yet. But if there are new features, then you want to have that on your local main branch so that when you build your repository locally, you look at your code, it's all up to date with things that Sam might have done while I was sleeping. Especially when you work on distributed teams where you're working with people from around the world on different time zones, this can be extremely, extremely valuable here. And this terminology is also just important to kind of distinguish. So when we talk about pushing code, we're talking about bringing our code that's local into the cloud. And when we talk about pulling, we're talking about pulling down from the clouds above onto our local machine. So it's just this imagery that helps you kind of visualize this tree and how things work. Great, so now that we know about git pull, we can talk about some good workflow habits with Git. Always git pull before starting work, especially on the main branch. You don't want to be creating what's called conflicts on the main branch, which is where you and I change the same line in a different way and now we have to bring it together. You want to just avoid that as much as possible, and pulling can help you avoid that. Use git status frequently to see what has changed, what did you already commit, what did you already stage. Commit often with focused changes. I briefly talked about how you shouldn't be doing 1,000 lines of changes and then having a git commit message that's hey, small changes or fix stuff. What you should be doing is really small commits that are easy to follow so that when someone reviews it and it's not overloading the reviewer. Something that we always joke about in the software engineering field is if you have a 100-line commit that you want reviewed, then someone's going to find a bunch of problems with it and say hey, change this design or you should do this differently. But if you accidentally submit a 1,000-line commit for review, then the person's just going to say this looks good to me because they don't even want to go through it and read it to find mistakes or find areas of improvement. And that's exactly what we don't want, right? We want people to say, hey, here's how you can do this better so that you can grow as an engineer and write really good code and build good products. But if you give too big of a commit, your reviewer just doesn't have time in their day, so they're just going to gloss over it and barely even give you the tools to become a better engineer. So definitely want to commit often with focused changes. And the last thing is to write commits like you're talking to your future self. One of the greatest things that my fiance, who's a brilliant software engineer, has taught me is that you should write commits like you're talking to your future self, because future you is a different person. When you look at this code in 2 months, you also want to remember what you did, and you should assume that you will remember nothing, because the more code you write, the less of it you remember. You don't want to wonder, why did I make this decision? What was this commit about again? I wrote updates, but what updates was I talking about? It's really good to think about things that way. And the last thing is the best standard for Git commit messages is conventional commits. This is a really good way of writing good, clear commit messages, so you can separate things into this is a feature, this is a chore, this is documentation, this is docs. This is a fix of a previous bug. Now your Git commit messages have this prefix, so you can programmatically organize them. If you wanted to, for some reason, look for all the documentation updates, you could look for the docs prefix in the commit and organize things that way. So just another little thing to expose everybody to. And then I think the last thing here is Python environment management. So we run into a problem if you have multiple projects where project A needs an old version of pandas and project B needs a newer version of pandas. And if you install pandas globally, meaning on your entire machine, then the first project is going to break. So the solution is to use virtual environments that isolate dependencies per each of your projects. and these dependencies are just the things that your project needs to work, right? And so what this does is it creates like a mini computer in your bigger computer, and that way you can have like one environment with pandas 1.5, one environment with pandas 2.0. They're not going to fight with each other. One is not going to preclude the other. So it's really helpful that way. Here are some steps to create a virtual environment using the built-in venv, or like venv is how we pronounce it, using that built-in venv tool that comes with your Mac. So I can do something like python 3-m venv myprojectenv. And so what this has done is it's created an environment called myprojectenv, and then you have to activate and turn on the virtual environment. So if I do source name of your env /bin/activate, now we're actually going to see it in the terminal header, which is another really helpful tool that I have. So this is telling me that I'm using, resources repo, main branch, v3.14 for Python, and then the myprojectenv. So everything's running in that mini computer. And then I can install packages with like the Python package manager pip, and I can say like I'm going to install pandas, I'm going to install polars into this virtual environment. So this is not on my like global computer, this is inside that confined virtual environment. And then when I'm done, I'm going to do deactivate, and now I'm exiting out of the virtual environment, so you no longer see it in my header. So like, it is here, and now it's no longer at the end here. And this is just such a pain because you have to like constantly remember to activate and deactivate it. Pip is really slow, so like installing packages takes forever, and it's just overall like not the best user experience. Like it could be improved, right? I'm going to clear and actually show you the modern solution to this, which is UV. I don't think it stands for anything, it's just like UV is this kind of ultra cool vibe. What you'll need to do is brew install UV, and this is again just going to update it because I already have UV, but for you, you'd probably be installing it for the first time. What this tool does is it automatically manages environments for you. When you use the UV run command, this is basically creating an ephemeral virtual environment for you while the script is running. And the reason this is so powerful specifically for Saturdata is that you can UV run Marimo notebooks, and it's going to install all of the dependencies at runtime so that you don't have to like install dependencies in an environment and then manage that the way that we just did. And if you want to install packages for your current project, you can keep a file of like all the UV packages that you want to use and then just like add things to it live. So if I do UV add pandas polar seaborn, then it's going to add those to a list, which I can actually show you here. If I ls, then you're going to see the pyproject.toml. So if I cat the pyproject.toml, these are all of the packages that we use for the resources repository. So like the project is resources, there's a readme in there, it requires a Python version greater than 3.12, which is why we're using like 3.14. And then we have all the dependencies. So like I can just add dependencies to this list here using the UV add command. And then when I do UV run, it's going to install all of these in an ephemeral environment and run them. So this becomes super, super powerful. And I'll show you how I'm looking at this notebook right now. So if I go to a different terminal window, I like to use command tilde to switch tabs. So what I've done here, I'll just zoom in a little bit more with command plus, is I've done UV run, Marimo run, and then I just have the path to the file. So it's running this resource at my local host, and that is literally how I'm showing you this right now. So let's unpack what's happening with this command, right? So the UV run is saying, hey, I don't want to worry about any virtual environments. Whatever packages are necessary from this pyproject.toml file, whatever packages I need in this dependencies list, you need to install them at runtime UV, okay? And so UV is going to handle that for me. All of my dependencies are exactly where I need them. Great. Then Marimo run. So the Marimo run is saying, take this Python file and run it and render it in the web as a notebook. So I'm combining and chaining these commands kind of, and that's how I got to this. And that's why we wanted to use Marimo and UV for this season, because look how easy it is. You don't have to install anything. You don't have to think about anything. You just have UV running your notebook in the web ephemerally for as long as you need, which is just so, so, so wonderful. So just to recap, there's like some different ways to run Python code, and they go from like worst to best in terms of how professional and like how good your practices are. So the worst thing is just like the system Python, which can break your system. So if you just like Python script.py, that's like the worst way to run your file. Then using Python 3 is a little bit better, but it's not isolated. It can be any Python 3 version. Some MacBooks still have like Python 2 versions, I believe, so like it's a little bit better because of that, but it's not great. The best thing is to use UV run Python and then your script.py, because UV is handling all of those dependencies. So it's always going to give you all the stuff that you need. It's never going to say, Panda's not installed, because it's doing all of that for you in the background. So just to recap, this is exactly how we launched this Marimo notebook. If you were in the root directory of resources, which is I believe where we are now, then you could just run this exact notebook. UV run Marimo run season 1 terminal resource.py. I could paste that in and it's going to automatically run for me, which is like so cool. So it's creating that virtual environment, it's opening the notebook anew, and that is exactly what I had actually done in the other terminal. So if I want to X out, I'll just Control C a couple times, but it's just so simple to get that virtual environment going. And I think we can end with some troubleshooting. So if you ever see a permission denied error when running your commands, you can ls-la to the problematic file and see like what are those permissions. And what you want to do is make the file executable. And this is just a fancy way for saying that I can run this file. And what you'll want to do is you'll want to say chmod plus x to the problematic file. Now, what does this mean? Every command means something, right? So chmod means change mode. And what I'm saying is change the mode of this file plus x. X means executable. So change the mode of this file to make it executable, and then I'll be able to run that file and I'll have permissions to run that file. If you have a directory, you'll use the recursive flag, which is -r, because folder requires you to like go into the folder and apply to everything within the folder. That's what we need with this R flag in this case. If you try to run something and say command not found, right? So like to my knowledge, Apple's not a command. So if I try to say like Apple, it's going to say command not found Apple, right? So what you can do is you can check if the tool is installed. So like if for some reason my Python command didn't work, I'd be able to say which Python, and then I say, oh, okay, so it's like pointing to a specific place, and I know like what that command is pointing to, because every command is just running code behind the scenes. If it is a real tool that you just don't have yet, you can install it with Homebrew. You can also check your path, which is like kind of an advanced terminal concept, which is saying like all of your commands are looking at something called the path. So when I say Python, it's looking to the path, and the path points at this actual like file path, which is where the code is stored in my computer. So you can add things to your path. If for some reason this was removed from my path, then I would not be able to find the Python command because it wouldn't be pointing to anything. So like more of an advanced concept that people can look into, but kind of a good intro to that. And then also Git authentication issues will come up when you're running these Git commands. So if you ever see something like permission denied, you can GitHub auth login, and that will just take you to the web to kind of log into your GitHub, re-authenticate you, make sure you have all your permissions that you need. And there are also different methods of cloning. So again, more of an advanced concept, but you can look at different methods of cloning like SSH to see if it's easier for you to authenticate and clone it that way. Last couple things here is like if you're ever having problems with package installation, even after you're using UV, or you're having problems with like package versions conflicting, which is what we talked about with like Pandas 1.5 versus Pandas 2.0, you can try a couple of things first. So you can brew upgrade UV, so that will get you to the latest version. You can clear the UV cache. Sometimes UV is like storing an old version of something that you don't need, so you can clear that. You can check the UV version before upgrading to make sure that like you're on the latest version. And you can also run with a verbose output using the -- verbose flag. That's going to tell you more of what's going on so that you can debug. Finally, we've arrived at our last section, which is very optional but highly recommended. So instead of using the regular terminal, like I mentioned, terminal, I use iterm, which is basically just a terminal that lets you customize, right? So you can do things like splitting the panes. I don't really like to do that, but you can cut this in half and have like more stuff going on. You have better search, you have customization. You can download it here. You can also use the Starship prompt, which is this beautiful informative prompt. It's not only like this gorgeous rainbow of red, orange, yellow, green. So I love Starship. Warp is a really cool modern terminal with AI features. It's designed for prompting, so it's also GPU accelerated, super fast. It's really cool, what we call IDE, Integrated Development Environment. So it's like an IDE that's also a terminal, and you can run these kinds of commands, and you can also ask AI, like, what is the capital of France? Whereas like in my terminal, that doesn't do anything, but Warp would know that that's an AI question, and I could still run commands like this. It would still like know the difference between what's a command and what's a question. And then color schemes, right? So that's what I've been talking about with Capuchin. I believe this is Capuchin Mocha. It's just like a nice typography font. It's pretty colors. And this sounds like super overkill, but it's really fun to have a nice experience if you're going to spend a lot of time here, right? Your apartment or your house is nice because you want to enjoy your time there, and I'm doing the same thing in my terminal. I'm making it actionable, quick, readable, beautiful for me. We also have some practice exercises, so you can practice like managing files, doing some Git stuff, The one thing we didn't talk about, I think, is the git init command. The git init command is basically just saying, like, take all these files and add git version control to them. And then from there, just normal workflow, like what we talked about. Practice Python with UV. And I think that brings us to the end here. So, like, what you've learned in this notebook is you've learned terminal navigation and file operations, git version control, Python environment management, running Marimo notebooks professionally, and how to troubleshoot common issues. You are ready for professional data science workflows. We've linked some resources for continued learning. Highly recommend always reading these docs and just playing around yourself, trying things, building projects, running into the problems, and having to solve those yourself. And a final reminder before we go is you don't need to memorize everything. You can always look things up. You can always use tab complete, focus on your workflows, and look up anything as you need it, because this learning curve is as steep or as quick or as slow as you need for your pace. So with that, thanks for watching Saturdata, and I'm really excited to hear what people think of the new season. Bye!